Smile, my boy. It's sunrise.
Hello everyone, it's me Arvind catching you on another Math Tutor Edu's lecture video. Okay, on the previous lecture video, I've explained to you regarding the radian concept, which we literally go through how to convert from degree to radian and radian to degree, and we have also understand the concept of radian in detail. Okay, so I hope you understand all that concepts in detail. In this lecture video, we are going to continue to the part 2, which is the length of the arc and the perimeter of the segment. Okay guys, so before moving on into our core content of today's lecture video, okay, so allow me to explain the parts of a circle in briefly, because some of the students until now they still don't understand radius, diameter, chord, segment, sector, okay, all these important terms which will be mostly applied in this circular measure chapter, but they don't know. Okay, so it's my duty to let you know guys in briefly. So let's quickly go through them, shall we? Okay guys, so this is the part of a circle which I literally meant about, and as you can see here, these are some of the important terms which you can find out over here, which start with the arc followed by radius, okay, center, okay, diameter, sector, chord and segment. Okay, so let us begin with the arc. Okay, arc is basically length of a curved line guys. Okay, so the difference between arc and a sector, so arc is basically a curved line, sector basically a area bounded by a curved line. Okay, so you can imagine a sector like a pizza piece guys. Okay, so from here proceed with the chord and segment. Okay, so the difference between a chord and a diameter, okay, the chord doesn't pass through the center point, okay, whereas the diameter pass through the center point guys. Okay, so that is the only difference between a chord and a diameter. Okay, so chord is basically a straight line, okay, which doesn't pass through the center point, okay, whereas the segment, which is basically a area formed by the chord guys. Okay, so this is the segment, okay, which literally form like a D shape guys. Okay, so this is the brief explanation regarding a parts of a circle. So I hope you understand the concept of a parts of a circle here. So back to our main lecture video now. Okay, so that is the quick explanation regarding the parts of a circle. So I hope those of you who don't understand, you guys are totally clear right now. Okay, without further ado, let's jump into our lecture video now.
Who's ready?
I'm ready.
Who's ready?
I'm ready.
Who's ready?
I'm ready.
Okay, let us begin our lecture video now. Okay, so let me draw a sector. Okay, another pizza piece again. Okay, like I said, if you're hungry, make sure you have your full meals now. Okay, it's just a sketch guys. Okay, sorry if it's not 100% accurate. Okay, so just imagine this is a sector of a circle. Okay, so you have a length of r. Okay, so this angle is denoted in the symbol theta. Okay, so this length of the arc here, so we denote as the letter S. Okay, so the formula to find the length of the arc, okay, so just let me write here. Okay, length of an arc, okay, so it will be equal to, so given by the length of the arc is in the letter S, so it will be equals to radius times with the angle theta over here. Okay, r theta. So technically to find the S, which is the length of the arc, so you need the radius and the angle theta. Okay, most important, the angle must be in radian. Okay, so this is the reason why you need to master the part 1 video guys. Okay, so that it will be useful for your part 2 video, okay, in this lecture video now. Okay, so this is the formula to find the length of an arc. So let me just make a box over here. So let's say for an example, okay, so let me just copy this sector over here. So the arc they don't give you, Okay, the radius, let's say for example, they gave you 10 centimeter. Okay, angle, they give you 60 degree. Okay, and you're required to find the guys, you're required to find the length of an arc over here, S. So if you come across in this type of situation, so what you're going to do? Okay, remember they already give you the formula, S is equals to r theta, and most important, the angle must be in radian. But then you see in this example, your angle is in degree. So what is the first step you need to do? Okay, the first step you need to do is you need to convert this angle into the radian form. Okay, from degree you need to convert into radian form. Okay, so once you convert this angle from degree to radian, then only you can able to find the length of arc. Okay, in this case the letter S over here. If you don't convert, you cannot apply this formula. This formula is only applicable only if your angle is in radian form. Okay, I'm emphasizing this strongly here guys, so please pay attention. Okay, so the step one, okay, let's say you come across in this type of case. Okay, so step one, okay, convert degree to radian. Okay, so this is the important step guys. Okay, so let us convert it. Okay, so from here 60 degree, okay, times with pi over 180 degree, okay, in a bracket, radian. Okay, so let us calculate this. Okay, let me bring my calculator here. Okay, it's good to have a online emulator guys. Okay, so let us do the calculation now. So 60, okay, times with, okay, where is the fraction form? Okay, so from here pi over 180. Okay, so the answer is coming out in terms of pi, but then we prefer to solve this using the exact number. Okay, so to get the exact number, you just click the shift button and the equal sign. So from here you get the angle in decimal form. Okay, so like I've mentioned in the previous lecture video, okay, it is safe for you to take up to 4 decimal place. So in this case will be 1.0472. Okay, so from here your angle will be 1.0472 radian. Okay, so this is your first step. So let me underline this angle. I don't know why the decimal is keep disappearing like a ghost. Is there a ghost around? Okay, just kidding guys. Okay, probably it's because of the computer glitch. Okay, so okay, so once you convert the degree to radian, okay, the next step, okay, find the length of the arc. Okay, so just write LOA in short form. Okay, LOA means length of the arc guys. Okay, so it is understood over here. Okay, so from here let's find the length of arc. So we're going to apply the formula S equals to r theta. Okay, so from here S is equals to radius, in this case is 10 centimeter. Okay, and then you times with the angle 1.0472. Okay, 1.0472. Okay, so you calculate this. Okay, so from here 10 times with 1.0472. Okay, give the answer in decimal, so you get 10.472. Okay, so for centimeter you can give up to 4 significant figures guys. Okay, so in this case your answer can be 10.47. Okay, so let me minimize this. So your answer will be 10.47 centimeter. Okay, so this is your answer for the first example. Okay, I wish in the exam the example could be as this easy. Okay, but this is for your understanding, guys. Okay, in the examination you can expect a combination of more than one chapter. Okay, let's say for example you can expect the solution of triangle concept to be involved within this circular measure. Okay, and then you can expect some of the ratio concepts to be involved in this circular measure. There are cases that I've come across of differentiation, okay, within this circular measure. Okay, the HOTS question can come out in any way, so make sure be prepared. Okay, so for the next example, okay, so let me explain to you briefly about the ratio concept. Okay, so I'm still going to use this sector. Okay, so let me just copy paste this. Okay, all right. Okay, so for second example, let's say you have two arcs. Okay, so you have S1 and S2. Okay, as you can see here, you have two concentric sectors. Okay, one for the involving the S2, another one is involving the S1. Okay, so let's say the one which involving the S2, the length is let's say for example, so the radius up to here is 6 centimeter. Okay, so and then for the S1, okay, which is 10 centimeter, right guys? Okay, so usually what the question will ask you is, they'll ask you to find the ratio of the length of the arc between the S2 and S1. Okay, so in this case, how are you going to solve? Okay, it's still similar. Try to solve the one which has the most information. Okay, so you have the angle here. Okay, you start one by one. So from here, you know that your length of the arc S1 is 10.47 centimeter. Okay, so now proceed to find the length of the arc for S2. So in this case, to find the S2, okay, you still apply the same formula, which is r theta. Okay, in this case, your radius is no longer 10 centimeter but is 6 centimeter. Okay, 6 times with the angle not 60 degree but the angle in radian form, which is 1.0472. Okay, so you calculate this. Okay, so 6 times with 1.0472. Okay, so let us convert this into the decimal form. Okay, so you get 6.2832. Okay, so this, since this is a length, so we will give up to 2 decimal place. So in this case, your answer will be 6.28 centimeter. Okay, so this is your length of the arc of the second sector. Okay, this is for the first one. Okay, so let's say you want to find the ratio. Okay, in order for you to find the ratio, the first thing you need to do is you need to convert the ratio form into the fraction form, guys. Okay, so from here, ratio of S1 over S2, okay, will be equals to, so from here 10.47, okay, divide with 6.28. Okay, So from here, your ratio of length of the arc S1 is to S2 will be equals to, so from here 10.47, wait now guys, okay, 10.47, okay, you divide with 6.28, okay, so convert it into the decimal form. Okay, wait. Oops.
I'm only gonna say this one more time, sir. Calm down.
6.28. Okay. So we try to simplify this. Okay, you get 1.67. Okay, so that means your ratio is 1.67 is to 1. Okay, so that means your length of the arc of 1 is 1.67 times higher than the length of the arc for the second one. Okay, so that is the explanation, guys. Okay, so let me underline this. Okay, so this one, so let me delete this. Okay, so this is the brief explanation behind the length of the arc concept, guys. Okay, in the beginning I've explained you so the formula, and then I've briefly go through the some of the examples. Okay, so how to convert to the radian, and then what are the possible questions that might ask you during the examination. Okay, so this is some of the possible questions they can ask. They can ask even difficult than this. Okay, I'm just giving you some of the overview. Okay guys, okay, so from here, so we're going to briefly go through the formula S equals to R theta. Okay, in the last lecture you have learned that some of the important value, which is 2 pi is also equals to 360 degree. Okay, I hope you still remember this, okay, during our radian conversion, guys. Okay, so from here, this 2 pi, okay, let's say you substitute into the angle here. So 360 degree, it's indicating a full circle. So let's say if you want to find a circumference of a circle, so R you times with 2 pi. Okay, so this 2 pi is technically in radian. Okay, so guess what it's coming out? So it's coming out as 2 pi R. So this is how the circumference of a circle formula comes out, guys. Okay, circle is equals to 2 pi R. I mean the circumference of a circle. Okay, so this is another important thing you should take note. Okay guys, okay, this is for your extra explanation. Okay, so I hope you understand the concept behind this. Okay, so 2 pi is equals to 360 degree and your pi is equals to 180 degree. Okay, so these angles you learn during your part 1, guys. Okay, if you haven't watched the part 1 video, so please click on the link above and watch those videos, then you come to watch this lecture video for better understanding. Okay, so this 2 pi is indicating the angle, total internal angle of a circle, so which indicates 360 degree. Okay, and this R indicates the radius of a circle. So full circumference of a circle, which means the full length of a circle, is equals to 2 pi R. So that's how you get the formula of the circumference of circle, which is C is equals to 2 pi R. Okay, so I hope you understand the concept behind this. So this is for your extra knowledge, guys. Okay, so we have already go through the length of an arc concept, so let us go through the perimeter of the segment concept. Okay, so let me draw another segment. Okay, so please wait, guys. So let us draw another segment.
Much later.
Oh. Come on. Okay, acceptable. Okay. So silly. Okay, so this is the sector of a circle. Okay, and let us draw a chart over here. Okay. So for those of you who don't know what is this is actually a chart. And this region bounded by the chart is known as the segment. Okay. So this angle still remains the same, is in terms of theta. Okay, and this is the radius of the sector. Okay. So from here, let us continue to our next concept. Okay. So from here, the formula to find the perimeter of a segment. Okay, so how do you find a perimeter of the segment here? So what is a segment? Okay, so a segment, consider the external length. Okay, in this case, the external length of a segment consists of a chart, okay, and then length of an arc. So perimeter of segment, okay, in this case is equals to length of an arc, okay, and then you plus with the length of chart. Length of chart. Okay, so from here let us continue. Okay, the length of an arc, okay, we know the formula, which is S equals to r theta. Okay, so which in this case is r theta. Okay, so r, okay, you times with the theta angle here. This angle is in radian, guys. Okay. Okay, and then to find the length of a chart, so this chart length over here. So how are you going to find? Okay, it is very simple. Okay, so it is 2 r sine theta over 2. Okay, so 2 r sine theta over 2. So this is the formula behind to find the length of chart here. So this is the complete length over here, guys. Okay, so I hope you understand the explanation behind this. Okay, so the length of the arc is basically the r theta, so which in this arc. Okay, to find the chart, okay, basically 2 times with r, the radius, okay, times with sine theta over 2. Okay, so now you know the formula to find the perimeter of segment. Okay, so which in this case is r theta plus 2r sine theta over 2. Okay, so this 2r sine theta over 2 is the length of the chart. Okay, so length of an arc is r theta over here. Okay, so let us go through one example before we end our lecture video for today. So let's say this angle we set as 1.4. Okay, and then the radius we set as 6. So we are required to find the perimeter of the segment. Okay, let me here write here POS, perimeter of segment. Okay, 1.4 radian and 6 centimeter. Okay, so to find the perimeter of segment will be length of arc. So in this case r theta. Okay, and then you plus with the formula length of the chart here 2r sine theta over 2. Okay, so let us find the perimeter of segment. So from here r theta will be, okay, 6 times with 1.4, okay, times with 2 times with the radius 6 centimeter, okay, times with the sine angle 1.4 divided with 2. Okay, so you calculate this. So let us open our calculator. Okay, but before that, it is better for us to change the mode into radian form. State. Okay, where are guys? Okay, so shift mode. Okay, press number 4. Okay, so now it's officially we set our angle into radian form. Okay, so let us start our calculation. Okay, so 6 times with 1.4, okay, and plus with 2 times with 6 times with sine, okay, 1.4 divide with 2. Okay, so is everything okay? Okay, so calculate this. So from here you should get your perimeter of segment is 16.13 centimeter. Okay, 16.13 centimeter. So let me underline the solution for this example. Okay, so and before I end this lecture video, the most important thing is before you key in your calculator, make sure you convert your mode into radian form. Okay, if you calculate this using the degree form, you will get a wrong answer. Okay, so make sure when you set your mode, make sure you click in the radian form. Okay, shift mode. Okay, you click the radian form, which is RAD over here. Okay, depends on what calculator you're using, guys. Okay, so I just want to remind you this. Okay, many of the students make this mistake especially. Okay, so we have come to the end of our lecture video. So basically we have just gone through the length of the arc, okay, and some of the basic formulas on how to find the perimeter of segment, guys. Okay, so we have finished our lecture video. So back to our main video now. Thank you so much for your support. If you like this video, make sure you click the like button to show your support, and also not to forget to subscribe to the channel for more upcoming lecture videos in the future. And make sure for the students, please do share this video to your friends. Thank you so much for your support, and I'll see you in the next video.